Okay, we're going to use this problem from our day one Riemann notes to review the process for calculating area using a left and a right Riemann. We're going to do this problem twice. We're going to do it with a left Riemann and then with a right Riemann. To remind us that this Riemann calculation process is being used to calculate the area under a curve, which is what an integral measures. If we wanted to call this oxygen function like O of t, where our minutes are in t, then what I'm estimating with my Riemann is the area under the O of t function from 0 to 5. What that will do is that will, since the O of t function is, in this case, a rate of change, we'll be calculating the area under a rate of change function, and what that will give us is a total, an accumulation of change. So let me use this example. We did a velocity time graph and the area under that being displacement, change in position. If we're looking at an oxygen production function, where the oxygen is being produced at a certain rate of cubic feet per minute at different minutes, we're going to use our left and our right Riemann to calculate the total amount of oxygen produced over the 5 minutes. So I'm going to start off with a graph, real quick sketch of the data on the table. You don't have to make a graph, okay, but it can help sort of emphasize the left versus right Riemann concept. And I'm going to be, let's see, 1, 2, 3, 4, 5. So we'll just kind of eyeball some of these. So 0 is 0, and 1 is 1.4, and 2 is 2.8, which is almost 3, and 3 then jumps down to like 2.2, and then 4 goes back up to 3, and 5 goes over 4, and so, something that looks like that. When we do a left Riemann, and in this case, we're going to do our Riemann rectangles with a width of 1 minute. My first rectangle is going to go from 0 to 1. And the weird thing about this first rectangle is the height, when I do a left Riemann, I have to do the height for the rectangle on the left side of the interval. Well, from 0 to 1, my height would actually have to be the height here, which is 0. So 0 to 1, I'm not going to have a rectangle in this left Riemann process. When I go 1 to 2, I'll do the height at 1. When I go 2 to 3, I'll do my height at 2. So this rectangle is 1 by 1.4. This is my first height. This is my second height. The first height is a height of 0, so this was sort of rectangle number 1, nothing. Rectangle number 2, 1 by 1.4. Rectangle right here would be 1 by 2.8. This rectangle, 1 by 2.2. So height, 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 height. And the last rectangle, the 4 to 5 rectangle, uses the 3, or 3.0. So when we're doing a left Riemann, the last function value, the last height, doesn't get used. we have 1, 2, 3, 4, 5 intervals, so 5 rectangles, and 1, 2, 3, 4, 5 heights. Oops, I don't want to move that. Now, if I grab my calculator and, oops, that's why it's not working, because I'm not pressing the right button. I wonder if I'm doing this on the wrong page. I think I am. All right, so let's see. This would be 1.4, 2.8, 2.2, 3.0, so that's 5, 8, 9.4, and it's 9.4 of what we were producing, 9.4 cubic feet of oxygen total over 5 minutes. Now, if we wanted to do the exact same problem, but with a right Riemann, and I sketch 5, 0, 1.4, 2.8, 2.2, same kind of approximate graph. Okay. What's going to happen when I do a right Riemann is each interval, I do the height according to the the right side of the interval. So 0 to 1, I'll do my height at the 1. So the first rectangle is 1 by 1.4. Rectangle number 2 is 1 by 2.8. Rectangle number 3, 1 by 2.2. Height, height, height. Number 4. And then number 5, 1 by 4.2. So in a right Riemann, I don't use the first height, or the first function values at height. I use every other one. So, or I use the rest of them, everything except the first number. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. 5 intervals, 1, 2, 3, 4, 5 heights. And so you'll notice, yeah, I've got a lot of the same calculations as the last time. Okay. I just have one that's different, the 1 times 4.2. So let's see if I kind of look at what we did here. When I put the 1.4, the 2.8, the 2.2, the 3.0, and the 4.2 all together, 12, 13, 14, 15, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4 is 13. Okay. 13.6, and then still cubic feet of oxygen over the 5 minutes. Okay. If you did not do the other 2 problems from the previous page yet, you should do those. You should go ahead and do this acceleration function, area under the acceleration function giving you a total velocity, and that would wrap up sort of those first notes for the left and right Riemann.